There's a circuit with a light bulb in it, and it's designed to find out how does the current go into the light bulb and then come out of the light bulb. And we want to find out, is the resistance of a light bulb actually ohmic or non-ohmic? Let's look at the setup of the circuit. First of all, we do need a voltage source, and right now we'll keep it a constant voltage source for the first part. Put a resistor in series with a light bulb. So essentially this is our circuit, a simple series circuit. Now to gain insight into how the electricity comes into the light bulb and out of the light bulb, what we do is we put 2 ammeters in the circuit. So I'll label this A for ammeter. Let's call it ammeter 1, and this is ammeter 2. And this will be voltmeter 1, so we can keep track of the volts across it. Now to figure this out, we will then record the value of the current here before it reaches the light bulb, and the current here after it reaches the light bulb. So we're gaining insight into how essentially how a circuit works. We'll notice that the current, we'll say I, going at point A1 here, okay, will equal the current at A2. And why? Because this is a series circuit. The current is the same everywhere, okay, in the wire. And the value of volts 1 is going to depend on, how much resistance the light bulb has while it's glowing, and how much resistance you put in the actual circuit there. So, pretty simple circuit. And this is something we do know already about circuits, but this is a way to experimentally prove, or demonstrate highly, we should say, how current goes through a circuit. It's the same everywhere. Now for part 2, what if I wanted to find out, is a light bulb resistance ohmic or non-ohmic? So ohmic means it obeys Ohm's law, V equals IR. So if we look at this, if we increase the voltage, put an arrow up for that, okay, and if the resistance remains constant, it doesn't change, then the current will just simply rise with that. And the resistance of it will be like a constant value. So it's directly proportional. So how will we do that? Well, the only change of the setup really needs to be, we change our 12 volts into a variable voltage source. I'll draw an arrow across that. So in other words, we can change the voltage on this. And we, of course, could measure the current and measure the volts on the actual light bulb. So I could put any volts on this and quickly record my current in either location. They would be the same, and whatever volts is on that. And what should the graph look like? Again, if it's an ohmic material, we're going to see a line or a graph that looks something like this. It'll start at 0 volts and just simply increase on a straight line in this direction here. So that the slope, okay, of this graph, okay, is going to equal, the slope is going to equal the resistance R. Okay, now if the resistance is non-ohmic, we could see maybe a curvature like this, or a curvature like this, and indicating that, as voltage changes, the current actually doesn't stay linear. So that would be something non-ohmic. And a light bulb, would have to be tested and to see what happens there. And it does turn out that a light bulb does have some temperature resistance to it. So as the temperature goes up and the light bulb may glow brighter, you're going to need to know that the resistance does increase, change on that. So, we're probably going to see, a graph something like this. The volts is going to go up, but current is not going to quite go up as steady. So we'll probably see a graph somewhat like this because of that difference there. So any material is ohmic will be a straight line, non-ohmic will be some kind of curvature.